So here you can see one solar PV system, okay, which is connected. This is the solar panel, PV panel, okay, which is connected to a boost converter here, where loads, distributed loads are connected, okay, and this MPPT, neural network based MPPT, okay, artificial neural network based MPPT. I'll show you everything, and the data you can see here, okay. Data, all the datas are I have written. You can as for conference paper, okay. I'll show you all the value. Let me just see it from the Simulink model first. Okay, one PV panel. We are running on irradiance, variable irradiance. Okay, time given and amplitude is given. Okay, this PV panel, I'll show you all the data. You can see, you can pause, you can take screenshot of the data here. And this is boost converter. Load is connected. Okay, load is connected. Here I can see the I have already run this model, so we'll see the load power and PV power. You can see here my screen is blinking down, so I don't know why. You can see the result. Okay, this one is PV power and this one is load power. And voltage also I'll show you. Okay, voltage, load voltage and PV voltage. PV voltage means directly from after this one. What I am measuring here. Load means after this PV panel, then boost converter, then distributed load. Okay. After this, whatever the result that is coming at this position, after this variable load, distributed load. Okay, that is load power, load voltage, load current. And I have this one. This neural network is created based on synthetic data. Okay, based on synthetic data, but the data is assumed, suppose for a single day. At first, here this data is not that one. Okay, 0.2. This one is for testing. But the synthetic data to train this neural network, I have assumed, suppose for a single day, irradiation will be at morning, it will be irradiation will be low, then high, okay, then again low at evening. So based on that, synthetic data is created to show you the data. Look, this this MPPT, neural network MPPT, is taking voltage input. Sorry, not this one. It's look like voltage and current input, but we go to inside. Look, sorry, it's taking irradiance and temperature data. Okay, and it's giving output reference voltage. Okay, this one is reference voltage. So what I did, I have created or assumed data like this. Look, 200, 314.29, it will go to 1000, then again will come to 200. Okay, so for a single day, if you assume that kind of data is given, and temperature also varied. Okay, temperature also when 200, temperature is 15 degrees. Okay, and total number of data I gathered or created synthetic data by using this code is 5,000, 50,000. Okay, here you can see the code. Show you the code. How can I create? You can use this code to get the training data set. Okay, means input data as well as output data. Okay, to train this network, this ANN network. Otherwise, you need to run this model. Otherwise, you need to run this model with a PNO or maybe any other before doing neural network. Incremental conductance, INC or PNO normally people do. So you don't need to go for that one because my target is not to compare this ANN MPPT with PNO or INC, but my target is to compare this simple ANN network with more advanced network. Okay, for creating this network, I have used this neural network toolbox. That one is in start. Okay, function fitting block. Okay, this fitting I have used where I need input data and output data only. Okay, this one I have used fitting one. Starting actually. Yeah, I just close it. If you want to know how to train, I have videos on that also. Okay, so I have already shows you the result. Bush converter, loads, uh, yeah, R1, R2, R3. Okay, I'm trying to show you everything. You can tune this PID here. Okay, let me show that confines papers. I'm just trying to make it ready. I'll show you the details here. The model is like this. Okay. This is the model actually. Okay. Push converter, then variable STP load, ANN, errors, and all. These are the parameter of the PV panel. Okay. Then boost converter details are here given. ANN parameter, whatever is used here. This is very basic ANN. Okay. Feedforward is used and trained with 50,000 data. Out of that, 15% is for validation and testing. 15%. Okay. This is the train. We got R exactly 1 because it's synthetic data. So that's like it's okay, more than okay, because it was very easy to get one because it was synthetic data. Okay. As the result I have already showed you. Load distributions is shown here. Generated power and load consumed. This one is very important thing. This generated power and load consumed power. Okay, load power. If you see this, then we can see that we need the battery. Okay, even without the batteries, the system is uh, working properly. So if you have anything, you want to know anything about this model, you can ask me, comment. Okay, you can comment. My next target is to uh, train this network with the realistic data. Okay, realistic data. We'll try to download the real data of irradiance and temperature. I'll train with that data, that model, okay, for MPPT, and I'll try to connect battery because battery needed. Without battery, it's working, but it's not a proper system. We can say without battery. Okay. For PV is if it is grid not, if it's islanded mode, so grid not connected. We show the voltage. Everything correct, coming correctly, okay. PPV, IPV, I is changing due to load, and that's it. I think if you have questions, you can ask in the comments. Okay? So bye bye guys. Have a good day.